Hi, it's Miss House. Let's take a look at the homework exercises from section 1.3. Let's do some sample problems. So the first question asks us to use the graph to determine the open intervals on which the function is increasing, the open intervals on which the function is decreasing, and the open intervals on which the function is constant, and in all cases, if any, because it may not be all of these. Now, there are two important things to remember. Number one, open interval means parentheses on both ends, okay? Don't include either end, parentheses on both ends. Also, when we describe increasing, decreasing, and constant, we use the x value or the domain values only. So we never look at the y ever. We don't even need the y-axis to do increasing, decreasing, and constant. We only need the x value. Now I'm going to pop this graph out and I'm going to look at it for a minute, and I want to point out that whenever the graph has an arrow or on the end, or even if it goes off to the very edge, as long as there's not a closed circle there, the graph is going to continue forever in whatever direction it's going. So we can depend on this graph to continue to go down and to the right. So it's going to spread out to the right and go down. On its left side, it's going to spread out to the left and go down. Okay, so we don't have to worry about it reversing course because we have to assume that that's what's happening. Now, if we want to know where the graph is increasing, we look for where it is rising. So if I put my cursor here, I notice that this graph is getting higher and higher and higher and higher until I get to here. Now, I'm going to ignore that too because that's a y value. All I want to know is the x value where it's rising, and see it stops rising here on the x of 0. So the interval over which this function is increasing is from parentheses negative infinity, comma, 0. Be very, very careful. A lot of folks will try to put that 2 there, but remember, we never use the y values. We only use the x values. Now they want to know where it's decreasing. So this graph is decreasing on this right-hand side and forever. And again, don't look at the y. It's from 0 to positive infinity. And I have to put parentheses on both ends of that interval from 0 to infinity. Now, the last thing they ask me for is constant. And constant means that the graph is neither going up or down, it's just flatlining. It's a horizontal line. And you'll see we don't have that anywhere on this graph. So for that one, we select there is no interval on which the function is constant. Okay, let's do another one. Here they ask me the interval over which the function is increasing, decreasing, and constant again, if any. Now, this graph is different from the last one because it doesn't have arrows on the ends. It has these solid circles. Even though it has a solid circle, though, you have to remember intervals for increasing, decreasing, and constant are always open, meaning there's always parentheses. Again, we're going to ignore these y values. We don't even need the y axis. We're only going to look at these x values. So if you'll notice, this graph is falling all the time. So it's never increasing It's never constant. It's decreasing, not from negative infinity to positive infinity, but from -4 on the x to 0 on the x. So that's the only one I can answer here. So where is it increasing? Never. So we just select the function is never increasing. Then we select the function is decreasing. And remember, we're going to use open intervals, so parentheses, and it was from negative. Let me look at that graph one more time. It was from -4 to 0 on the x. So -4 to 0. Got those parentheses there, and I didn't use a y value. And the function's never going to be constant. So we're going to select the function is never constant. All right, here's a graph. Again, they ask us to find increasing, decreasing, and constant. Now be careful because they don't always ask it in this order. Increasing means the graph has to be rising, and you'll see this graph is never rising. Decreasing means it's falling, and you'll see this graph is falling here. We don't look at the y's, we look at the x's. That arrow means it's going forever, so negative infinity to 1, it's falling. And this time we do have constant because look, it's flat on the right-hand side. So we've got decreasing on this end all the way down to x is 1 from negative infinity to 1. And then we have constant from 1 to infinity. So the function is never increasing. So there's no interval over which the function is increasing. And it's decreasing, we said, from sorry about that. It is decreasing from negative infinity to x is 1. Remember, we saw that graph. It was decreasing everywhere over here until we get to x is 1, using parentheses, never using a y value. And we see that the function is constant this time because it's flatlining from 1 to infinity. Here's another one. Use the graph to determine the open interval where the function's increasing and where it's decreasing. And what you're going to see this time is that there's more than one place where it's rising. There's more than one place where it's falling. Ignoring the y values, we only want these x values. Look, it's rising until I get an x -4. It's also rising from -3 to 2. So from negative infinity to -4, and from -3 to 2, it's rising. So that means it's increasing. So parentheses, negative infinity to -2, comma, now we don't use a union symbol or anything like that. We're just listing these separate intervals, -3 to -2. Let me see why I missed that. Got to find my glasses. Hold on. Okay, let me look again. Let's see. Oh, it's to -4. Okay, so let's clarify that. Make sure we get it. It's rising from negative infinity to -4 and from -3 to -2. That's right. Now it's decreasing also over two different intervals. So look, it's falling from -4 to -3. That's decreasing. And from -2, not to negative infinity, but to positive infinity because we're looking at the x values. So the function is decreasing. One second, let's see what happened there. Okay, I had a little technical issue there, but let's look at what the answers are. The function is decreasing on the interval from -4 to -3, -4 to -3, comma, -2 to infinity. So let's look at that one more time. Look, it's falling here, but we're describing the x values. This arrow means it goes out and it also spreads out. So from -2 to infinity. That's where it's decreasing. All right, now it wants to know where it's constant. And looking at this graph, look, this is a nice curvy curve. There's no flat in this graph at all, so it's never constant. Now, before we go to number 5, let's just recap what we just said. Okay, so for intervals of increasing, decreasing, and constant, you're going to use number 1, use interval notation. Number 2, use x values, that's domain values only, and parentheses on both ends. That's because increasing, decreasing, and constant are open intervals only. That if it's increasing, the graph is rising. If it's decreasing, the graph is falling. And if it's constant, the graph is flat. And it may not be any one of these, okay? So you just have to see, is it rising, is it falling, is it flat? Now we're going to look at maximum and minimum. Now, think about this. Maximum, of course, get rid of this for a minute. Pause it if you need to copy it. I just noticed that I've misspelled increasing. So let's correct that. Sorry, I don't have editing on this video today. Increasing, spelled correctly. Thank you very much. Okay, so increasing, decreasing, and constant. Use interval notation, x values only, parentheses on both ends. The graph is rising if it's increasing, the graph is decreasing, it's falling, and if it's constant, the graph is flat. All right, now let's talk about maximum and minimum. When you have a graph, okay, it may rise to a peak, okay? If it does that, this is called a maximum. Okay, it's the highest point on the graph. Okay, now a maximum occurs at x, its value is y. So this is true whether it's a maximum or a minimum. Where it's happening is the x value. What it actually is the y value. Now you may also have a graph that's falling. So let's make one where the graph does something like this. Okay, so notice how this graph has a low point down here. So that's called a minimum. And again, it's going to be occurring at x and its value is y. So let's take a look at this graph. In this graph, you will see a low point here at -2, a low point here at 0. Notice I'm not saying the y value right now. I'm just saying where it occurs at -2 and at 0. And you see a high point at -1. Now, the actual value here is the y value, which is 0, because look, I'm on the x-axis. The same thing here. It's 0, and the high point is 4 at x equals -1. Now, notice how they want us to write it. The function has a maximum at, look, the maximum was at, here it is, it was at -1, at -1, and its actual value we saw was 4. So where it's at is the x, and how much it is the y. That's the maximum. Okay. Now this time, the minimum, there were 2. It occurs at x is -2 and 0, and each time the y value is 0. So the function has relative minimum at, and they are, and so we're going to have to separate these with commas. So the minimums were at -2 and 0, they are both 0. So -2 and 0, and it's actually 0. Now I'm pretty sure we don't have to write that twice. Let's check and see. That was true. Since it's the same, I didn't have to write it twice. Now, if they were both different values, I would have to also separate those with commas as well. All right. Now let's talk about even, odd, and neither, and whether the graph is symmetric with respect to the y-axis, the x-axis. I'm sorry, the y-axis, the origin, or neither. Okay, so even functions. This is the definition of an even function. F of x is the same as f of the negative of x, or the opposite of x. You will recall that we did some evaluating functions in a previous section. Well, if we substitute negative x into the original function everywhere there's an x, and these sides come out equal, then we know that we have an even function. If we have an odd function, f of x is the opposite of f of the negative of x. So if we put in negative x for all the x's in the original function, and it comes out to be every term opposite, we know we have an odd function. Now, when you have an even function, you have y-axis symmetry. And when you have an odd function, you have origin symmetry. Let me show you examples of these. Okay, so I'm going to go out to this site called Desmos, and I'm going to show you an even function. Y equals x to the second. That's an even function. How do I know? Because it is symmetrical around the y-axis. See this y-axis right here? The left-hand side and the right-hand side are perfect reflections of each other. If I add a term, it may or may not still be symmetric. For example, I add a 4x, and look, it's no longer symmetric about the y-axis, so that wouldn't be an even function. Let's do another one. So here's an even function, x to the fourth plus 2x squared. It's exactly the same on the left as it is on the right. So that's even functions. Now let's look at an odd function, x to the third. In the case of an odd function, we say it has origin symmetry. If you flip it upside down, it looks exactly the same. Think about this. If I flip this guy, rotate it around the origin, it would look exactly the same. Okay, let's let me snip this and show you what I mean. So I'm going to do print screen. I'm going to go back over here. Go back to my picture for a second. All right, so you see this right here. Here's my original function. I'm going to rotate this 180 degrees, and look, it looks exactly the same as it did before. Again, rotate it 180 degrees. Here's the original. Rotate 180 degrees, looks the same. So that means I have symmetry about the origin. So an even function is going to have y-axis symmetry, and an odd function is going to have origin symmetry. So how do we do that? Well, we look at what happens when you put in a negative x for x to see if it comes out the same, even, or opposite, odd. So let's see, our first function they gave us is x to the third plus 2x. So let's see if I've got f of x is x to the third plus 2x. F of the negative or opposite of x would be, yes, I got to put it in parentheses, negative x to the third plus 2 times negative x. That would give me negative x cubed, because think about this, negative times a negative times a negative is a negative x cubed. And this will give me a positive times a negative minus 2x. Now notice that this was positive, it is now negative. This was positive, it is now negative. So since the signs are opposite, and then you can always use that to help you remember, opposite, odd. Yes, both of my signs were opposites, so this is an odd function. Now, this is one of those where if I turn it upside down, it's going to look the same, right? So what kind of symmetry does it have? It has origin symmetry. Let's go out to Desmos and look at that. X to the third plus 2x. Now, you're not going to have the graph, so you've got to do it algebraically, but I want to show you why the symmetry is what we say origin. So here it is. Here's the picture of x to the third plus 2x. I take it over here. Here it is. And watch what happens when I rotate it 180 degrees or flip it upside down. Look, it looks the same. That means this is an odd function. So it has origin symmetry. Odd origin, opposite. Odd origin, opposite. Remember that for the O's. It's an odd function. It's going to have symmetry about the origin, and all the signs have to be opposites. Okay, now we have x to the 6 plus 4x. So my function is f of x equals x to the 6 plus 4x. F of negative x would be negative x in parentheses raised to the 6 plus 4 times negative x. That's going to give me x to the 6 minus 4x. X to the 6 minus 4x. Now, if it's odd, they have to both be opposites. If it's even, they have to be the same. So look, this one stayed the same, but this one changed to its opposite. So this is a neither because they have to both be opposites to be odd. So taking a look at this in Desmos, x to the 6 plus 4x, you can see, look, it doesn't have symmetry about the y, and if I flip it upside down, that point's going to be at the top instead of at the bottom. So this one is going to be a neither. And it has no symmetry. Okay, no symmetry. Okay, one more. X to the 4th plus x to the 6th plus 4. Okay, x to the 4th plus x to the 6th plus 4. Now, you don't have to do this, but in standard form, that x to the 6th should be in the front. Okay, you don't have to do it, but customarily, you would want this to have exponents that descend in order. We're going to do f of negative x to the 6th plus negative x to the 4th plus 4. And look, even exponents, an even number of negative signs is going to make this a positive, and this a positive, and this is going to stay plus 4. So look, this is identical to the original. That's an even function, and it will have y-axis symmetry. So it's even, and it has y-axis symmetry. Okay, now we're going to look at what's called a piecewise defined function. So let's talk about what that means to be a piecewise defined function. If you have a function that is divided into more than one piece of the domain, for example, I'm going to start with a simpler one than that one, but let's just say I've got x plus 1 for the x values that are less than 0 and x minus 1 for the x values that are greater than or equal to 0. This function divides the domain, that is the x values, into two different sets, right? Here, for the negative values, you have to plug into this part. And for the positive values, you have to plug into this part because look, x is positive and 0 here, x is negative here. So if they ask me to do something like f of 5, I have to first locate where would 5 be? Well, 5 would be in the greater than or equal to 0 part. Therefore, I would evaluate it in this part. So I would say 5 minus 1 is 4. So f of 5 would be 4. So I just want to make sure that I pay attention to which piece I should be using. So let's take a look at the one they gave us. Evaluate the piecewise function at the given values of the independent variable, f of negative 2. See if I can get both a board and this here. Okay. So if I'm going to do f of negative 2, I have to look for the right piece of the function. So let's see, negative 2 is in this piece because it's less than 0. So I would say 5 times negative 2 plus 3 is negative 10 plus 3 is negative 7. Then they asked me for f of 0. F of 0, I look at the pieces. 0 is included in the bottom piece, so that would be 4 times 0 plus 5. 0 plus 5 is 5. F of 1, I look for the piece that 1 is located in. Well, 1 is greater than 0, so 4 times 1 plus 5 is 4 plus 5 is 9. So same thing here. They want us to evaluate the piecewise function at the given value of the independent variable. So h of 3, now notice they say x can't be 6 here. That's because it would make a 0 denominator. So they've assigned if x is 6, then the function or the y value has to be 4. But they just asked me for h of 3, and let's see, that can't be the second piece because it's only x equals 6. I have to put it in the first piece. So that would be h of 3 would be 3 squared, subtract 36, over 3 minus 6. I need to do the numerator first, 9 minus 36, then the denominator, 3 minus 6 is negative 3. That will give me a negative 27 divided by a negative 3, which is 9. So H3 is 9. And now, excuse me, and now they ask us for H of 0. And let's see, H of 6 is the bottom, got to be in the top. 0 squared minus 36. 0 is not 6, that's why I'm using the top one. Over 0 minus 6, that's going to give me a negative 36 divided by negative 6, which is 6. So h of 0 is 6. And then they asked me for h of 6. H of 6. Well, if x is 6, that's the bottom piece. So the answer is 4. There's nowhere to substitute the 6, so the answer is just 4. It's a constant. Now in this one, they've asked me to graph the piecewise function and to determine the range that the graph covers. Now, to graph a piecewise function, the best thing to do is to make a chart x, f of x, or xy. Remember, f of x and y are the same thing. And you're going to do this for each piece, okay? Negative 4x is for x less or equal to 0. And negative 4 is for all x's greater than 0. Now, whenever you pick the x values, you must start with the value that's shown. So the first one here is going to be a 0, and the first one here is going to be a 0. Now the additional points I pick, and 1 or 2 more points is fine. On this side, they have to be less than 0, so I'll pick negative 1 and negative 2. And over here, they have to be bigger than 0, 1 and 2. Okay, now to find the function value, I must substitute these in everywhere I see an x. So negative 4 times 0 would be 0. Negative 4 times negative 1 would be 4. And negative 4 times negative 2 would be 8. Now, it's important that I notice that x can actually be 0 here. So this is going to be on the graph. But when I move to this point, x can't equal 0. So the first point, 0, negative 4, has to have open circle at that point. So I don't include it, but I need to go up to it. So I start with it, and I put these circles around it to remind me, since it's not included, I put an open circle on the graph. But since this is a constant function, look, there's no x here, these turn out to be negative 4 all the time. So I'm going to be looking for, on the left side, ordered pairs 0, 0, negative 1, 4, and negative 2, 8. Those are some points on it. On the right side, I'm going to be looking for an open circle at 0, negative 4. Circle that open. Then the points 1, negative 4, and 2, negative 4. So I go over to look at my graphs. The first one, yes, it has 0, 0. Negative 1, 4, that makes sense. Negative 2, 8, that makes sense. Then the other piece, 0, negative 4 with an open circle. Let's make this bigger. 0 with a negative 4 and an open circle. 1, negative 4, 2, negative. It looks as though A is going to be my answer. Now let's talk about why these aren't our answers. In this one, this can't be my answer because look, this part has to have negative 1, positive 4. But look, if I go over here to negative 1, and these are 2, 4, 6, 8, 10, so be careful. These are in 2s. It's down here at negative 4 instead of up here at positive 4. So that can't possibly be my answer. This can't possibly be my answer because, well, let's see. We're supposed to have the point 0, 0 included on the graph. And look, at first it's an open circle, but also look at negative 1, it's at negative 4 again. So that can't be. And this one can't be my answer because they have the constant or the flat line on the left instead of on the right. And if I go to 0, 0, look, it should be included, but then I'm supposed to go to negative 1, 4. That one's right, but look, negative 2, 8 is not right. So this one is also not the correct answer. So A is the correct answer. All right. And now I have to do the range. Now let's go back and look at this graph. So the range is the set of all y values that are included on this graph. Now, you can see here the y value of negative 4 is included. And you can see here that all these y's, look, I'm looking at the y's now, from negative infinity, right? I'm sorry, from 0 to positive infinity, looking at the y's, you read y from bottom to top. So look, 0 going up, 0 to infinity, and then negative 4. So my range does have an isolated value and an interval. So the isolated value was the negative 4, and the interval was from 0 to infinity. Now, this is the range. So whereas when we did increasing and decreasing, we didn't include certain points. But look, we've got to include this point, y is 0, all the way up because this is the range. And we do use inclusive brackets to say that that is included. And then negative 4 was the other one. Okay, here's a similar one. The domain of the piecewise function is negative infinity to infinity. Graph the function and then use the graph to determine the range. I'm going to make two charts because it's in two pieces. Now, if it's in three pieces, you need three charts. X, f of x, x, f of x. And the first value in my chart is going to be the value where the domain changes, negative 4, negative 4. For this piece, I pick values less than negative 4, negative 5, negative 6. For this piece, I pick values that are greater than negative 4 or equal to negative 4. So negative 3, negative 2. Notice it is included on the second piece, so I'm going to put my open circle around that point right there, whatever that turns out to be. Okay, now to evaluate, we just take these values and we plug it into the correct piece. So negative 4 plus 1 is negative 3. Negative 5 plus 1 is negative 4. Negative 6 plus 1 is negative 5. And for this piece, I'm supposed to subtract 1. Negative 4 minus 1 is negative 5. Negative 3 minus 1 is negative 4. And negative 2 minus 1 is negative 3. I'm just going to go ahead and graph it. Instead of looking at those graphs, I'm just going to draw the graph. So for the first piece, go to the left 4 and down 3 and put an open circle. And then to the left 5 and down 4 and put a closed circle. And then to the left 6 and down 5 and put another closed circle. And that's what my graph looks like here. It goes right up to x is negative 4, but you have an open circle there. Now for this piece, I'm going to have a closed circle at negative 4, negative 5. So negative 4, negative 5 is going to be down here. And I'm going to put a closed circle. Negative 3, negative 4 is going to be here. Negative 2, negative 3 is here. And this piece looks like that. And we assume it keeps going. We could have picked other values, but these were the only values that we needed. Now, the critical part is that you start both pieces at the break point. If it's not included with an equal sign, you're going to put an open circle. So I remind myself by circling that and making sure I put an open circle there. Okay, plot the points, and then you can find the graph, and you can look at these three graphs, and graph A is the only one that's anywhere remotely close to that. Now they want us to find the range. Now remember, the range is the y values that are covered. Look, this arrow indicates this graph keeps going forever up, and this one forever down. So every single value from on this y-axis would eventually be covered. So we say the range is negative infinity to positive infinity. Now, sometimes you may have a gap, and you've got to be careful, but in this case, all the y's were covered. All right, next one. The domain of the piecewise function is negative infinity to positive infinity. Those are the x values. Graph the function and use the graph to determine the function's range. So look what we have here. We have constant function because there's no x in our function. We've got a 6 if x is less than or equal to -1, and we've got a -6 if x is greater than -1. I'm still going to make my charts, f of x, two pieces, two charts. Start both charts with the break point, which is at -1. These, it says less than -1, so -2, -3. These say greater than -1, so 0 and 1. And you can do 1 or 2 points, and that should be sufficient. Now, I go back and I look and I say, okay, this one's included, but the second one is not included at -1. I'm going to put a circle around this to remember to put an open circle on my graph. Now, notice this says that x, no matter what x is, as long as it's less than -1, you get a 6. So look, I put a 6 on all of these. And over here, if x is bigger than -1, I get a -6. So I'm going to sketch this out. -1, it's 6. -2, it's 6. -3, it's 6. And I could keep going forever in that direction. And this end point at -1, look, that's at -1, it's a solid circle. This piece says at -1, -6. -1, -6, but I have to put an open circle, okay? For one thing, if I don't put an open circle, I don't have a function at all because that would violate the vertical line test if I have a closed circle on both places. Then I get 0, -6, that's here, and 1, -6, that's here, and this would keep going forever in this direction. So this is what my graph would look like. It's up here at 6 for the values including -1 and any number less than that. And down here at -6, not including the value at -1, all the way to the right, including all those values. So my answer is, in this case, graph B. Now, there's only two values that y can be. Look, it crosses y down here at -6, and it crosses y up here at 6. There are lots of gaps on this graph. Only these two y values. So we have more than one, what they call an isolated value. So the single value of -6 and the single value of 6. So I just list -6 and 6.